Alright class, video number 2, monoatomic ions. By gaining or losing electrons, many main group elements form ions with noble gas configurations. For example, group 1 metals lose 1 electron to give 1+ cations, such as sodium. Take a minute and let's go over to the periodic table and let's check it out. Group 1 elements are right here, and they're saying they lose 1 electron to have a noble gas configuration and make ions. Well, that makes sense. Can you tell me how many electrons group 2 will make? Hope you say 2. Let's continue reading. Okay. Group 2 metals lose 2 electrons and give 2+ cations such as magnesium. Ions form from a single atom are known as monoatomic ions. That's a good quiz question. Nonmetals of group 15, 16, and 17 gain electrons to form anions. For example, in ionic compounds, nitrogen forms 3 negative anions and 3 minus. The 3 added electrons plus 5 outermost electrons in nitrogen atoms give a completed outermost octet. Similarly, the group 16 elements, oxygen and sulfur, form 2 negative anions, and the group 17 halogens form 1 negative ions. Look for these in the periodic table. Do you see a trend? Not all main group elements readily form ions, however. Rather than gain or lose electrons, atoms of carbon and silicon form covalent bonds in which they share electrons with other atoms. The other elements tend to form ions that do not have noble gas configurations. For instance, it is difficult for the group 14 metals, tin, and lead to lose 4 electrons to achieve a noble gas configuration. Instead, they tend to lose 2 electrons in their outer p orbitals, but retain the 2 electrons in their outer s orbitals and form 2+ cations. Tin and lead also can form molecular compounds, in which all 4 valence electrons are involved in covalent bonding. Elements from the D block form 2+, 3+, or in a few cases 1+ or 4+ cations. Many D block elements form 2 ions of different charges. For example, copper forms 1s and 2+. Copper forms 1+ and 2+ cations. Iron and chromium each form 2+ cations as well as 3+ cations. And vanadium forms 2+ and 3+ and 4+ cations. Real quick summary, what's it saying? It's basically saying, hey, if it's an element in the D block, which is here, it could form a variety of different cations, 1+, 2+, 3+, or 4+, depending on the situation. So, what are you writing in your notes right now? Maybe you should take just a minute and write down monoatomic ions and a couple of the main points that you read about. When you're ready, let's continue on. Please continue on. Naming monoatomic ions. Monoatomic cations are identified simply by the element's name, as illustrated by the example at left. Here's potassium ion, magnesium cation. If it's a cation, if it's a plus, it's going to have the same name as the element. Naming monoatomic anions is slightly more, please turn the page with me, slightly more complicated. First, the endings of the element's name is dropped. Then the ending "ide" is added to the root name, as illustrated in examples at right. So here's the element fluorine, and when fluorine gains an electron to get the perfect 8, it becomes fluoride anion. Nitrogen, nitride anion. So if it's negative, it ends in "ide." Interesting. The names and symbols of the common monoatomic cations and anions are organized according to their charges in Table 1. The names of many of the ions in the table include Roman numerals. These numerals are part of the stock system of naming chemical ions and elements. You will read more about the stock system and other systems of naming chemicals later in this chapter. All right, take a look. Notice the positive 1 charges are lithium, sodium, potassium, rubidium, and cesium. Well, wait a minute, Mr. Worley, that sounds familiar. It should sound familiar because look at group number 1. Lithium, sodium, potassium, rubidium, and cesium. they all lose one electron to form the cations. You bet that group 2 is going to lose 2. Some of group 3 will lose 3, and so on and so forth. I mean group 13. All right? So basically, I want you to know all of these monoatomic anions and cations. I want you to know the name and the charge and the symbol. So if I say vanadium 2, you'll say V2+. If I say chromium 3, you'll say Cr3+. That is a memory assignment for this chapter. All right. Please go to the next video.